Question 6 asks for determination of the splitting patterns for each of the indicated protons in this molecule drawn below. So I'm going to start with the aromatic ring. And if we look at this proton here, we can see that it's adjacent to one other proton. So our initial thought might be that that proton would split into a doublet. However, if we draw a line right through here, we can see that this entire compound is symmetric. And because it's symmetric, the proton that we're looking at is actually equivalent to the one that it's next to. Because they're equivalent, they don't split each other, and at that position we end up with a singlet. Now, as we continue around to the left, we can look at this proton that I have highlighted in orange. This proton is adjacent to just one other proton, so 1 plus 1 gives us a doublet. Continuing around our ring, we can look at the proton indicated in purple. That proton is adjacent to 2 protons on each side. But the 2 protons on each side are not equivalent to each other. So we end up with a 2 plus 1 and another 2 plus 1, or a triplet of triplets, and 9 total peaks. Continuing around the ring, let's look at this next one highlighted in blue. This next one in blue, again, has 2 CH2s that are adjacent. The one we looked at a moment ago in purple, and the one on the other side. But the one on the other side, again, because of the symmetry, is equivalent. Because it's equivalent, it's not going to split, and this proton that we're looking at, the one highlighted in blue, is split only by the one above it in purple into a triplet. If we go over here, this one in pink is an identical situation to the one that we looked at in purple. It has 2 CH2s that are not equivalent adjacent to each other, adjacent to it, again giving us a triplet of triplets. Our next hydrogen indicated in yellow has 2 hydrogens on one side, so that's 2 plus 1. On the other side though, it's only 1 hydrogen, so 1 plus 1, giving us 6 peaks. And then our last hydrogen here has a methyl that's next to it, so that's 3 plus 1. On the other side it has a CH2, 2 plus 1, or 12 total peaks.